Hi, welcome back to the statics review session. This session you learn about frames. So what are frames? In the last session, um, we covered trusses, and I said that trusses are structures that are composed of members that are considered as a two-force members. Two-force members that are connected both at both ends with a pin, and there's no force in between. Weight is neglected, and therefore the resultant reaction at the pins at both pins actually pass through or share the same line of action. Here in that case, RA and RB. If there's any force in between, this will change the resultant line of, so the two resultant won't anymore be in the same, share the same line of action, and this is in this case is not considered anymore as a two force member. Two force members are subject to tension and compression, but here you have also bending has to be included with that. We call these members multiple force members, structures that are composed at least with one multiple force members. We call them frames. So, for example, this frame is composed of two members that are connected with a pin at B and pin connected or pin supported at A and C. If we try to find the support reactions at A and C, the maximum we can get from the structure is the vertical supports. But because they both have horizontal reactions, it won't help us. The only way to find the support reaction, also finding the pin reactions, is to take them apart at the pin and draw the free body diagrams of both parts. Here you notice that now we see the pin reactions. When they're connected, we don't see them. They are not shown, they cancel each other. But when they are connected, we just have to show the pin reactions, and then we draw them. They are equal and opposite in direction. So you have bx, it's the same as bx but it's in the opposite. By is by, the same but opposite. And we have the pin reactions or the support reactions at A and C. This way you can start then applying equation of equilibrium on each section separately, where I can start with this one or I can start with this one, or you can also start with that one too. So maybe I start with here, find the vertical supports. Now I reduce these to three unknowns. Moments about the point, it gets you the x, vertical and horizontal gets you the bx and by, and so on. So just moving from one system to the other. Let's see this in a numerical example. This beam is fixed at A, and with a rocker support which acts as a roller support at B. It's also pinned at C. If we draw the support reactions, then a fixed support would resist vertical uh, movement, horizontal movement. That's why we place the vertical and horizontal, and it will also resist rotation or moment effects. That's why we place a moment reactions. Rocker support is like a roller support that will have just a vertical support. Now, this beam now has four unknowns. You want to be able to find it using the applying equation of equilibrium. Maybe the maximum you can get is the x component of the A support by applying the sum of the forces in the x direction. So, what should we do? At this pin, we should just disconnect the beam and then draw it separately. So you have these two parts of the beams disconnected at the pin, and then we draw also the support, the pin supports. The vertical, they are drawn equal opposite, and the horizontal equal and opposite in direction. Um, and then we start applying equation of equilibrium. On that member that has the least number of unknown, and obviously the right hand part of that has only three unknowns where you can apply equation of equilibrium. You find these two, you can find which will be known here, and then you can find the other on the other section. Please notice that it doesn't matter what assumption you give, like we give this as an assumption, calculation will show us if this is correct or not. So following, we just apply equation of equilibrium on the right hand side because it has the least number of unknown, or three only. We started with forces in the x, and you're using the 500 and then 513, 5 that's the horizontal component, and minus x. So and then applying, you get that x is 192. You notice here that we just use that the positive is in that direction. It's up to you. And now that's the first unknown we found, which is the horizontal component of the pen reaction. Followed applying to, we can start with forces in the y, so let's start with a moment, and we can start with a moment about point C. So you have the by, that's the positive rotation counterclockwise, times moment arm is 12, and then the 500, the vertical component, which is 12/13th, multiplied by the 4, the moment arm, and it's rotating negative. And then finally, don't forget that there's a couple moment with a 2500, and it's rotating rotating clockwise, which is negative. We have the by only as an unknown. We solve it. You get the value or the magnitude, 362 pounds for the by. And then for f of y, to get the cy, so you have cy moving downwards, by is upwards, and then the vertical component 12/13 times 500, and you solve it, you get that cy is 99.4, but it is in the negative. Now you need to have very good attention here, because you get that cy is a negative, which means this is not the right direction. We have to turn it. So now we turn it here, but once you do that, then you have to turn it on the other side too. Many forget to turn it on the other side, and then when they start applying equation of equilibrium here, they do the mistake and find wrong answers. So very important, you find that that negative, change it, and change it on the other side too. So we start applying equation of equilibrium on this side. Forces in the x gets you that x, cx, and equal cy, equal ax, and forces in the y direction, you have ay positive, cy now negative, and then the resultant of that triangular shape distribute load is the area of that triangle, where the height is 110 and the base is 8, so it's half 110 times base, height times base. That's the area of the triangle, and that's the resultant. And then you solve it, you get that the ay is 539 pounds. It is positive, right assumption. Continue, get some of the moments about A to get. Now the remaining is that to find this moment, and so counterclockwise is positive, that's why MA is positive. And then we have for this distributed load, that's the resultant, which is half 110 times 8, and then the moment arm, which is the centroid of a triangle that acts about 2/3 of that distance 8. So, and this is 2/3 times 8, That's the moment arm. So you have, this is the resultant, this is the moment arm, and rotating clockwise negative. And then finally you have the cy, and then multiply it by 8, rotating also clockwise negative. We substitute the value for cy. Here you substitute the value, the positive value. Remember that we changed the direction. Please don't make a mistake. That we changed the direction, which means that you would substitute for 99.4. It's because this is the negative rotation, right? So this negative sign is is the sign for the rotation, and then you substitute only with the 99.4 because we changed the direction of the force. Finally, calculate, and you get that is the moment reaction at the support at A, 3.33 kip foot or kilo pound foot. Final note, please pay very good attention when you work with the pin reactions, especially if you give an assumption and then you get a negative answer for this assumption. You change it and then you change it on the other section right away. Many mistakes happens, as I told you, by forgetting to change the direction when you use it to work with the other section. Also, when you know that you change it, you don't need to use this negative sign anymore, as long as you know that direction, this negative sign represent the direction. Another note, the moment arm for the triangular shape, if you take a moment about this point, so the centroid of a triangle is a 2/3 from that side and 1/3 from that side. So if you take a moment about this point, then you use the 1/3. Thank you very much, and see you in the next session.